Okay. Can you see
Yes,
the screen?
yes, yes.
Everything is all right now. Yeah. So today we are starting with harmonic mean. This we haven't started. What idea you have about harmonic mean, Abhijit?
Uh, you see, although I do have an idea, I want to learn from you. That is why I'm here. I mean, I do, but
No, no, no. See, I was my question in that way to like extract something like like you are learning or not. No, I just wanted to have a general idea. What do you know about this?
you see, it is used for. I mean, that was not my response as well, but it is one way of calculating the returns on a portfolio.
Um, no, you are like not precise on that. See, it like any mean is all about average, correct?
Yes,
It's
yes,
not returns, but it's average returns. We can say precisely, correct?
yep.
So yeah, many folks are confused like so much of stuff is loaded here and why we use this harmonic mean and all. See, a harmonic mean is like something. Let's say what textbook version is. Harmonic mean is used for certain computations, such as average cost of shares purchased over time. It doesn't give us a great idea about this. See, we are using mean as well, correct? But again, why harmonic mean? But let's see the formula. It is n by summation of 1 by xi, where there are n values of xi. Okay. So let's take this arithmetic mean and harmonic mean and compare this two. Okay.
Hmm.
Then we'll get a good idea about why are we using that. So this is arithmetic mean and we'll see harmonic mean. So harmonic mean is nothing but this one is like x1 plus x2 plus x3 by 3. Okay, this one is n by 1 by x1 plus 1 by x2 plus 1 by x3.
Mm-hmm.
Okay, so like whenever you see ratios kind of things, here there's no ratio, am I right? Here there's ratio. So if I take you in the finance world, PE ratio, P ratio is a ratio, no?
Yes, sir.
So when you get ratios, harmonic is a better like method to find out the average. Okay, but now why? See, I'll give you a practical example. You
Yep.
consider an example. Okay, there's a class A students and there's class B students. Okay, you want to find out what's the average score of students. Fine. So there is a problem, like which is that in class A there is one student who got 100. Okay. See, some student is getting 5, some is getting 6, some is getting 8, but one of the guys got 100. But why it is a problem? Because it may shoot up the average, which is what was a problem with arithmetic mean, because it's an extreme observation and mean gets distorted because of extreme observations, correct?
Yes.
And you get a false sense of performance of average, false sense of average performance from class A, correct? So from to get rid of these kind of scenarios, you can use harmonic mean at times. Okay, but how? See, in harmonic mean, we will give a lesser weightage to extreme values. That means if this is 100, we will give lesser weightage to this. What we'll do?
Lesser weightage to extreme values.
Yeah, I'll tell you how. We'll give lesser weightage to extreme values and we will give more weightage to regular non-extreme values. And I'll show you how.
Weightage to, okay.
Correct? So I'll put a small this thing in front of you. So class A and class B, and there are like students like 1, 2, 3, 4, and these are the like let's say this one. And the marks what they scored is 25, 25, and then 23, 23, and then 25 and 25. But here 100 and here 40. Okay, and I calculated the harmonic mean. Let's say it comes out to 30 and it comes out to 26.9, and here the arithmetic mean comes out to 43.3 and 28.3, and you can see the arithmetic mean is very high because of this outlier, correct?
Yes.
But harmonic mean in both the cases is very nearby, and it is very near. It gives a real sense, real picture. But now you would be again asking me how like this is possible and this weightage and all. See, if I take 1 by 25 here, Abhijit, if I take 1 by 23, if I take 1 by 25, and if I take 1 by 100, what is happening, Abhijit, here? If I take this in percentage terms, it is 1%. Am I right?
Huh.
If I take this in percentage terms, it is 4%, correct?
Yes.
So to which I'm giving more weightage and to which I'm giving less weightage?
You
More weightage, and here?
less. Okay, in case of harmonic mean, yes, we are giving more weight.
Yes, that is what. So if we do this, then the real picture, the real arithmetic, the real harmonic mean, if we find the real harmonic mean comes out to be the entire total of this is 0.13. Since you have 4 observations, 4 by 0.13 gives you 29.96. Okay, and mean no one would believe in this case because it's an extreme observation. So in this case, what is the mean which is more trustworthy? Harmonic mean, correct or wrong?
Yes.
That is comes around 30. Okay, so you understood now why we use this.
Yes, sir.
To the highest observation, you give the least weightage. That's what, and you try to rule out the extremity. That's what. So technically, students won't think all this, but it is very important. Now, if they frame you, if they give you some questions of MCQ kind of, so then you will be in issue. So there's a question here. Please solve this, Abhijit. See, if the data is normal harmonic mean, because I already told you, na, in case of ratios and all, you will be most often using harmonic mean, like P ratio and all, correct?
Okay. 1,000.
Suppose if they ask you, they give you 5 P ratios, and they'll tell you the average P ratio. That case, harmonic mean you will be using, because this P ratio will be a ratio, correct?
Yes.
That's what. So generally what happens is the like harmonic mean and arithmetic mean are almost identical thing. But as we keep progressing, adding more values, then simple average or the arithmetic mean, it overestimates the mean. So there harmonic mean makes sense, correct?
Okay. Yeah, I think we can move on. Yeah.
Did you do this?
Yeah, I've just done it. Okay, okay. See, I used the formula and solved till the 8.926. Now, what is this they've done?
No need. Now this is what they wanted and you got it. That's it.
Oh, okay.
So Abhijit, you need to solve these questions. And some point is lift. Okay, okay. And Abhijit, I wanted to know something like what is this trimmed mean and vinsorized mean something? This is okay. This is okay. This is okay. What about this two?
See, trim mean is possibly you can take the higher the extreme values on top and bottom, and you can take the mean of the values that are in the middle.
Yeah, that means you don't want the data to stretch more. You try to fix them. Correct?
Yeah.
That means, see, vinsorized or trimmed mean almost are like something which is very near. So what you do is, let's say I take a data 3, 14, 16, 16, 17, 29, 34, 36, 39, 47, 59, 64, 65, 66, 68, 79, 91, 98. I know it's a very big data. So we will do some vinsorization here. 90% vinsorization will do. Okay. So we
Okay.
would first find the 5th percentile and the 95th percentile, correct?
Okay.
So 5th percentile is like 12.35 and 95th percentile is, let's say, 92.05, correct? So
Okay.
what we will do now is we'll try to trim this data. We'll remove this useless thing and we'll start from 12.35. Okay. And
Okay.
we'll remove this useless thing and we'll finish it. We'll take the data, all the data, and we'll put it last 92.05. That means we'll take the between numbers and we have eliminated some extremities, correct? Outliers, and we fix the things between this. That is visualization, correct? Trimming also is almost the same thing. You are just removing the outliers. Am I right?
Okay.
Correct, na?
Huh. Hello.
Yeah. Now let us go for the next one, which is quantile. So quantile is the general term for a value at or below which a stated proportion of data in the distribution lies.
Okay.
So there are some examples of this quantile as well. Okay. And one of the examples here is quartile, quintile, decile, percentile. See, what I'll do is I'll
Yes.
just simply take a data. Okay. And I will divide the data into four parts: 25%, 25%, 25%, 25%. Can I say that is quartile?
Not sure actually. So,
Yeah, quartile is division of data in four parts.
okay, fine, fine.
Okay. Now, see, I'll just give you a data. So let's say, let's take out an example for this. Let's say here, suppose I make a graph. Okay. This is a complete thing. I divided that into four parts, correct? I made it four boxes, na?
Yes,
Hello.
there's four boxes, yeah.
So I divided this data into how many parts?
Four parts.
And this is the lowest data. This is the this zone consists the lowest data. This zone consists the highest
Higher.
data, correct?
Yeah.
And this in the between one consists the
Okay.
average.
Huh.
50% of this, 50% of this. It is average, na median. Am I right? The
Yeah.
middlemost thing is mean, median, whatever. This is a 25% part, 25% plus. Lowest data, highest data. This is average data, correct? So if
Yeah.
you divide the data into four parts, it is quartile. If you divide the same data into five parts, it is quintile. Same thing I'll do for you. 1, 2, 3, 4. So 20%, 20%, 20%, 20%, 20%. Lowest, highest, average comes between third quartile here in middlemost one, correct? Third
Okay.
quintile. This is the first quintile, second quintile, third quintile, fourth quintile, fifth quintile. So in third quintile, you get the average. First quartile, second quartile, third quartile, fourth quartile. This shows the one by fourth region. This half region, 3 by fourth region, one region, correct?
Okay. So
This is
in
one
the second example, you told me the middle portion comes in the third quartile. That's accepted. In the first,
quintile, not quartile. Yeah.
okay, okay. And I said quantile, na? So it still makes sense. And in the first example,
No, no,
the
no. See, Abhijit, why are you taking me today? What happened to you? I don't know. I didn't hear your voice properly.
okay, you see, in the first example,
See,
you give,
let me be sorry to interrupt you. Quantile is something, these all are quantiles only. But this is specifically quintile. Okay. Quartile is a kind of quantile. Quintile is a kind of quantile. That's what. Yeah. Now tell.
yeah. So in the first example, so where does the average come in the second quartile or the third quartile?
It comes here exactly in between this. Here. 50%, na?
50%. I mean, so
Between third and fourth. No, between second and third it comes, na? This is first, this is fourth, this is
agree.
second, this
Huh.
is third.
Because okay, fine. It is neither a part of the second or the third. No, so that is why I'm confused.
No, neither the part of second, neither the part of third. It is 50%, boss.
Okay.
And here it is 20, 20, 40, 40 plus 10, 50. 10, 20, 20, 50. Correct, exactly in third quintile, correct?
Okay.
Hello?
Yeah, got it. Thank you. Yes, sir, we can move on. Yeah.
Yeah, and again, division of some data into 10 parts is decile and 100 parts is percentile. There is a formula to find out all this. And like note that any quantile, they may be expressed as percentile. For example, the third quartile partitions the distribution to a value such that 3/4. I already told you third quartile is 3/4 or 75% of the observation fall below the value. Yeah, when we see the third quartile, 75% of the values lie below this, na? Correct or wrong?
Yes.
This is exactly the third quartile part. Till here it is the third quartile. Now, so the formula to find out any of the quantile would be n y into n plus 1 by 100. Okay. So now here we will see. Yeah, we will see. I'll show you. So if you want to find out the third quartile for this. Okay. So this y tells the percentage. What does it say?
Y is a percentage.
Percentage. N is number of terms. So how many number of terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you have to arrange in ascending order, correct?
Oh,
So
okay.
arrange the data in ascending order, count the number of observations, 10 observations, and see what are they asking. They're asking you what? They're asking you third quartile, correct?
Okay.
So for third quartile, what we'll use? We'll say this, we know that the 75% is third quartile, correct? It has the 75% data. Isn't it
Oh,
so?
yeah.
So we take 75% here. 75. Okay, 75 by 100. If it is first quartile, we take only 25 by 100. That makes sense. Okay. Or else you can do one thing. N into, if I take n plus 1, can I take this like into, if third quartile, na? 3
Yeah.
into n plus 1 by fourth term. Can I take this? Can I take this?
Well, you'll get the same answer, but how
Same,
did you
no.
arrive at?
What?
Acha. Okay, okay, okay.
It is the
That's
same thing, na? And 1 into n plus 1 by fourth term. Okay, so I can write it n into n plus 1 by fourth term for quartiles. Here n would be third quartile, first quartile, second quartile is always a median. Everyone knows that. Fourth quartile. So you take the number here and the number of terms here. Understood? This shows the quartile number. This shows the number of terms. Understood?
okay.
Okay, better go with the textbook version.
Yeah,
Okay.
yeah, yeah. That's what I
That,
was thinking.
yeah, I won't tell you about this, but the textbook version is clear and you can go through that. This is what we generally, many of the students in MBA and all, they use this formula.
Okay. Yeah.
Just a second. So whenever you check anything, any website, they use this formula as well. First quartile, n plus 1 by fourth term. Third quartile, 3 into n plus 1 by fourth term. Okay. And if you want to find out decile or percentile, then what will you do?
The 10th term,
If I tell
because
you the 10th, if I tell you 10th decile, okay. So 10th decile would be 10 into n plus 1 by 10th term. Understood?
okay.
And if it is, if I tell you 95th percentile, so 95 into n plus 1 by 100th term. Understood? You can
Okay.
make a note of this. So I'm moving forward, Abhijit.
Yeah, please. I just wrote it down. You can move forward.
Yeah, yeah. So this is whisker and like box and whisker plot, largest observation, smallest observation, and between lies the median. So we will start measures of dispersion. Here we speak about range, maximum value minus minimum value. Dispersion is what, Abhijit?
Volatility in one way or the other.
Yeah, how much you are getting dispersed or how much you are going away from your mean. That's what is dispersion, correct?
Yeah.
Find out the range.
Okay, this is just the highest minus lowest, no?
Yeah,
Highest observed value minus lowest observed value, no?
yeah.
I think we
So
can move forward.
dispersion is like uh, extent to which a distribution is stretched or squeezed. That means if I take this, the distribution is very much stretched. That means you find a lot of data here. If I take this, the distribution is very much squeezed. A lot of data is here near
Yeah.
the mean, correct?
Yeah.
That's what is dispersion. So dispersion means like it's nothing but the spread. How's the data is like spread? How much the data is spread? Correct?
Yeah.
So the range what we saw shows the range. That means the data is between what values? Okay. Now mean absolute deviation. See, mean absolute deviation is nothing but you already know that x minus x bar can give you negative values, correct?
It can, yeah.
But that you are eliminating if you are using mean absolute deviation. You are only taking the absolute change, not the actual change. Understood?
Okay.
So you are only taking the absolute change, you're not taking the actual change. So I don't find this much more in usage, but still we have to study some errors, like some rectification has been done. So mean absolute deviation is the average of absolute values of deviations of individual observations from the arithmetic mean. So you're only taking the absolute values of deviation, not the exact values of deviation. For example, 10 minus 20 would give you minus 10, but you only take 10, which is the absolute change it shows, correct? It doesn't
Right.
show you the exact change, it's absolute change. Now, why are you doing this? Because there's a property in mean, na? Sum of the deviations is always equal to 0. So you are ruling out that, you are eliminating that here, correct? By taking the absolute values, you are eliminating that uh, characteristics of that property, isn't it so?
Yes, yeah.
So some of the actual deviations from arithmetic mean is always 0, but some of the absolute deviations from arithmetic mean, that means you have already ruled out the deviation sum to be 0 by taking the absolute change here, not taking the exact change. That's what it is. So you can see here, there are some values here, and you found out the average, and then you took the deviations from the observations, and you put modulus here. Modulus immediately removes the negative content, and then you get
Okay.
the mean absolute deviation. Okay.
Yeah.
So what does it mean? Deviation is nothing but how much
So could
deviation you are going to see from your mean.
yeah,
You're
could
going
you
to
just
see.
hold on for 1 minute? I have to take a call.
Okay.
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 Yeah. Yeah. Sorry about that, sir.
Yeah. So your mean happens to be 22% and it will deviate by 4.8 in the right side and 4.8 in the left side. Because out of modulus, when you take something out, it is plus or minus, correct?
Huh.
So it can be 26.8, or if you remove 4.8 from that, 17.2. So this can be your like due to deviation, this can be your means. That means this much deviation you will see either sides. Next comes the variance. See, we want to find out the volatility. right now we have just seen the deviation, but how to calculate the deviation? So you know that the deviation can be calculated through standard deviation, correct?
Huh.
But then I'll ask you a question. If standard deviation you want to calculate, why are you calculating variance then?
So variance can go either way, up or down. So it can come in a positive or negative. So if you just square the value, you will get the.
No. How come standard deviation also goes up and down?
Okay, let me rephrase my answer. You see, if the true value is 10, you may get a value of 8 and 12. So 8 is a negative 2, and the difference between 8 and the true value is negative 2, and the difference between 12 and 10 is positive 2. So when you add them all up, you get a 0.
Hmm. So
So
what?
so that's why you square the value, and when you take a root of it, you get a positive number which
Standard
shows.
deviation.
Yeah,
Yes.
it
You
shows.
then, since we know that the sum of the deviations, like from the, like some of the deviations, whatever you have taken from the observation, some of the deviations of the mean, correct?
Yeah, yeah.
The deviations from the mean, the deviations from the observation of its mean, whatever you have calculated, and when you added up that one, you always get 0. Okay, so to remove that, we square, and then we remove the negative values, and all the values will be positive. Then what we get variance, and when we make a when we find out the square root of that, we get the standard deviation. Okay, because standard deviation you cannot find out directly, because when you add up all the deviations what you've taken from the observations, whatever the deviations from the mean you have taken for the observations, when you sum it, it is 0. So it will not give you any answer any point of time. So to find out the standard deviation, it's very important or essential to find out the variance. Without variance, you can't find out the standard deviation. Okay. So that's what they have done. They have found out the mean, and they have taken the deviations of the mean from their observations. If you would have not squared, that means you would have taken 30 minus 22, 12 minus 22. What would have got?
Yeah, I'm not too sure. Yeah, looks like a 0.
0, correct.
Yeah.
So that's the reason why we squared it, and we got the variance here, and we found out the square root of that, and we got the what we say, the standard deviation. I think they have calculated in the next one. Yeah, they have calculated the standard deviation here. It's 0.0667. That is 6.67%. Okay, and that will be like the mean would be here. Okay, and the deviation of 6.67 either sides. But one thing I would like to ask you: both of the standard deviation and variance calculate volatility. So when will you use this? In what context you will use them?
I think standard deviation is a better measure, but if you are asking for a specific use case, I'm not too sure. I do not have an answer.
See, standard deviation, if you are looking for something like area, if you want to see the volatility in this case, then variance would be the right measure. Why? Because area is always measured in terms of square meters, correct?
Okay.
Area is measured in terms of square meters, and variance also is in terms of square, correct or wrong?
Yes.
But when you speak about length, it's always in terms of meters, and volatility in this case can be measured only through standard deviation, because root of square meters is meters, correct or wrong?
No, I didn't understand anything, to be honest.
See, if you want to find out area of something, what is the see, some formula would be there, but what would be the measure of area? How will you measure area of something?
Length into breadth, assuming it's a
That
rectangular.
is formula, Abhijit. Square meters in terms of square meters. The unit is square meters, na?
Agreed. The unit is square meters.
Yeah, 3 meters length into 2 meters breadth is 6 meters square or square meters. So in that case, variance will come into picture, na? Because variance is in terms of square only. Variance is in terms of squares, Abhijit, because you are making a square root of that to find you are just whatever the variance you get, you are putting it under square root, and you're getting this standard deviation, na?
Okay, fine.
Hello.
Yes, sir, understood. Please. Thanks.
So if this square meters is in terms of squares, root of this will be meters, na Abhijit?
Yeah,
Root
meter
of,
into, yeah.
see, acha, ठीक है. Meter square is what? Meter into meter.
Meter,
Correct?
yes,
Under
yes.
root of meter square is meter. So when there
Okay.
is meter, standard deviation. When there is meter square, variance. Finished. Both the things are different. Na? Volatility measure in both the things would be different. Here you can't use standard deviation. It is in terms of meter square. Here you can't use variance. It's in terms of meters. So general usage. Okay. Now you got it.
Yes, sir. Please.
Relative dispersion is the amount of variability in a distribution relative to a reference point or benchmark. See, we are going to find out the coefficient of variation. Okay. What does it show? The formula for coefficient of variation is standard deviation by average or mean. So coefficient of variation measures the amount of dispersion in a distribution relative to distribution's mean. We see how much is the dispersion, okay, or how much is the deviation from the mean, correct?
Could you repeat? Your voice was slightly off. Could you repeat?
See, we coefficient of variation
Uh-huh.
measures the amount of dispersion in a distribution relative to distribution's mean. That
Okay.
makes us to understand much more about the volatility, correct? So let's see here. A direct comparison between two or more measures of dispersion may be difficult. For instance, suppose you are comparing the annual returns distribution for retail stocks with a mean of 8% and an annual return distribution for a real estate portfolio with a mean of 16%. A direct comparison between the dispersion of two distributions is not meaningful because of relatively large difference in their means, correct? So how to make comparison and how to see how much dispersed they are, we will do that with the help of coefficient of variation. So it will, you will understand in a better way. Let us see coefficient of variation. You have just presented report. You have just been presented with a report that indicates that the monthly mean, the standard deviation here is 0.36, correct?
So your voice is
It
extremely.
shows less volatility.
Sir,
Can
I'm
you can
not.
you hear me now? Hello.
No, sir. No, sir. Nothing I've heard for the past 2 minutes. And your screen is also stuck. I'm not too sure whether.
Okay, Abhijit, 2 minutes. Can you see now?
Mm-hmm. Yeah, I can see in the screen now. Yeah.
Can you hear my voice?
It is. I think the connection has gone bad again.
Yeah. Just give me a second. I'll have some water and come. 2 minutes. Okay. Hello. Hello.
Yeah, yeah,
Hello. Yeah. So like here there is T bill, and the mean of the T bill, the mean return is 0.25. So as you know, coefficient of variation is nothing but standard deviation by mean, and the deviation is how much? 0.36. Mean is 0.25, and it shows 1.44. And the S&P is what we say, the deviation is this, and mean is this, and the coefficient of variation is this. Okay. So what does it show? Which is more volatile, Abhijit?
by numbers, S&P.
S&P is more volatile and T-bill is less volatile, correct? So more volatility is good or less volatility is good?
More less volatility is good.
Okay. So like in the sense the risk is less in T-bills or S&P?
The risk is less in tables.
Yeah. So these results indicate that there is less dispersion risk per unit of monthly returns in T-bills than S&P. Why? If the coefficient of variation is high, that means it shows more dispersion. This shows less dispersion, correct?
Yeah.
Less dispersion, less risk. That's it. So just we will do this. What is this? Calculate and interpret the target downside deviation. So when we use variance and standard deviation as risk measures, we calculate risk based on outcomes, both above and below the mean, correct? In some situations, it may be more appropriate to consider only outcomes less than the mean in calculating risk measure. In this case, we are measuring downside risk. So see, downside risk is what? We only take the downside thing. Understood?
Okay.
Let's say calculate the target downside deviation based on the data in preceding examples for a target return equal to the mean 22% and for a target return of 24%. So what we'll do, we already have the target returns here, correct? 22% and 24%. We are going to see the deviation from mean. Okay. So these are the returns here and the mean is 22. In this case, we found out the deviations and we found out the deviations. And when we what are we doing here? The formula for target downside deviation. This is the formula for target downside deviation, correct? That is xi minus b the whole square by n minus 1. And b is what here? Target, correct? So we can square this. We can square this. What do you get this here? Minus 10 the whole square plus minus 2 the whole square. So our target here is to take only what, Abhijit, the downside thing, correct? Downside deviation. What are we going to take?
Downside.
Hello.
Yeah.
What
Downside.
is downside What is downside deviation? The negative values.
Yeah. Yeah.
And
So what are we
so
doing with
downside deviation.
the?
We are going to find out something here. The deviation only. But here the deviation is downside deviation. So what we when we took this as mean and this as mean, the downside deviation is how much?
Okay.
5.10. Here 6.34. So what do you see? Which is more volatile?
The 24%.
That's what. So we only take the downside deviations here. Fine. So Abhijit, you can work out till here. Can we do this in the next session? Skewness,
Kurtosis.
kurtosis, and correlation. Nothing more than that. Kurtosis is fourth moment. Okay, that is x minus
Sir,
x bar the whole power 4 by n. Hello.
your voice was breaking up. I did not hear anything. Could you please repeat?
Kurtosis is nothing but it shows the shape. It is the fourth moment. What is that?
The fourth moment.
The first moment is x minus the first moment is mean. Okay. Okay. What is the formula for mean? Sigma x by n. What is the second moment? The standard deviation or the variance. X minus x bar sigma x minus x bar the whole square by n. Here the value will be either positive or negative. Here you will get two values, positive as well as negative, correct or wrong?
Yeah.
So this is called second moment. This is called first moment. Okay.
Sir,
And then comes
yes,
this.
your screen is stuck. Your voice is also breaking up, so I'm not able to follow, to be honest.
2 minutes, Abhijit. Yeah. Can you hear me now, Abhijit?
Yeah.
Hello.
Yes, sir, I'm able to
Hello.
hear you. Hello.
Yeah. Yeah. Yes. I can hear you. This is called the first moment, Abhijit. What is it called?
Oh, you wrote so much, is it? Okay. Your screen was stuck.
Yeah.
I
This.
wasn't able to see.
Yeah. This is called first moment, Abhijit. Mean is called first moment. Standard deviation is called second moment. Moment is nothing but shapes, Abhijit. Hello.
Yeah, yeah.
And standard deviation can give you two values, na? Negative as well as positive.
Yeah.
And then comes the skewness. Skewness is what? Sigma x minus x bar the whole cube divided by n. So skewness is what, Abhijit? Either right skewed or left skewed, correct?
Okay.
That means the data in right skewed, your maximum data is lying in the right side tail. Your maximum data is lying in the right side tail. I'll give you a good example for that. Don't worry. Just I'm giving a small hint about all this. And that's the reason why your data is skewed now. The outliers are pulling the data. What are the outliers doing?
Pulling the data.
Yeah, the outliers are pulling the data because most of the time maximum data lies in the tail. So, and that to right side. See, this is a normal distribution. I'll give you a small example. Don't worry. This is a normal distribution. See, you are asked to come to your office almost 8 a.m. in the morning, correct? That's the average. So in 365 days, you have to follow this norm. But you are almost coming at 8:30, 8:45, 9 p.m. So most of the time you are coming later, you are coming on time.
Most of the time I'm coming on time.
And that is extreme now. They won't tolerate all this. So your data will be skewed now. Understood? Because the entire data is lying here. Correct?
Yeah.
And you're always coming at 7 a.m. Your data would be skewed here because most of the time you're coming very early, too much early. That also they don't want. That will be again an element of doubt. So coming very early is also not good. Coming very late is also not good. Okay. If you're coming at 8 a.m., your data will be in symmetry, the same thing. So this is skewness. Skewness is nothing but, and in skewness what happens, Abhijit? See, in this symmetry, mean is equal to mode is equal to mean is equal to median is equal to mode, correct?
Yeah.
But in skewness, what will happen? Your mean will come this side. Your median will be here. Your mode will be here. So which is the one which is getting affected because of extreme observations?
The mean.
Which is getting affected, Abhijit?
Mean, I don't know. Mean.
That's the reason why the data is very skewed. Lot of time you're coming very late, and that is the reason why it is the normal distribution curve now changes to this. It's called right skewed curve, and this is called left skewed curve. Okay. Then comes to kurtosis. We'll discuss in the next session, Abhijit, about this. Some details are there. We'll discuss about them. Next session would be the final class of this particular chapter. Okay.
Thank you.
So what we have is only these three things, and again we have correlation and covariance also. That also we'll discuss. That will also be in the this chapter, portfolio management. Okay. When will we have the next class, Abhijit, so that we can finish this chapter?
It's going to be on Friday, sir.
Friday. Okay. Friday is the deadline, and Friday is the end of this chapter. Okay. Just a second. Wait. Okay, we are here. This is done. Friday, this will be done. Probability is done. Okay, so Saturday we can target distribution. Saturday and Sunday distributions will be done. Then sampling and hypothesis testing. Coming next week, your statistics should be done, Abhijit. Okay. Then we'll start economics. What do you wanted? We'll start that only, economics only. Fine. Sure. Okay, Abhijit then. Yeah, see you on Friday in the same. Right, what time Friday?
Friday, what time will you be free, sir?
Same time, 9 p.m. I'll be free, Abhijit.
You see, on Friday, if an afternoon class is possible, I'll give you a call. Is that okay?
Abhijit, Friday afternoon. After, yeah, what time you'll say afternoon?
Can I just confirm on
Yeah, you
Thursday?
can confirm me, Abhijit. But okay, this time is all right, Abhijit, for me. I'm exactly available at 9 p.m.
Oh, okay. So, okay, fine. I understood. I'll take a note of it. Thank you.
Yeah, okay. Then okay. If at all any possibility is there, you just message me. If it is like if you can message me your timings, you can let me know. If I'm available, we'll take the class. Okay.
Sure, sir. Sure, sir. You see, Thursday afternoon, I'll give you a message whether I'll be
Yeah.
coming. Okay?
Yeah. If I'm available, I'll definitely take the class. No, there's no problem.
Sure. Thank you. I'll call
Thank
you on Thursday, in fact. I'm planning to call you on Thursday.
you're calling me? Okay, call me. Call me.
No,
Yeah.
no, no. I'll call you on Thursday is what I meant. That's all.
Oh, okay, okay. You can call me, Abhijit, Thursday. If Thursday also you're available, you tell me. I can take the class.
Okay, fine. Thanks.
Okay, 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 Abhijit. Yeah. Thank you. Bye bye.